but bits might change.
Right, everyone, we're going to start the first talk of the evening. If you could all have a seat, please. Right, for the first talk of the evening, we're going to have Phil talk to us about remote working. Phil?
Hello. Is this mic working? Can you hear me? Not very well.
It's probably only for the stream.
Okay. Do I stand in front of this?
Should be fine.
Let's check.
Sorry.
That's right.
Let's try. I'm gonna give you a little.
Hello. Is that any better? Yeah. We'll have to make do. Okay. Yeah. My name's Phil, and I'm going to be talking about remote working. This is what I'm going to cover, a bit of context about why I'm talking about this stuff, some pros of remote working, cons of remote working, when you arguably shouldn't work remotely, and some tips I found to make it work. So a bit of context, why am I talking about this stuff? As I mentioned earlier, I work from home. Been working from home for about 1.5 to 2 years. And all that time, and prior to working from home, I've been thinking about it, I've been talking about it, I've been reading about it. And it's hard. It's really hard. Robin actually did a talk. He covered this a little bit in a talk a few months ago, and he mentioned it's hard. It's hard. I think it's hard because it's not the norm. Most people spend their careers in office. Take people out of the office and you work from home, it's just a different situation. You've got to deal with different problems, and it requires learning, basically. It requires a lot of thought. And why did I decide to work from home? There wasn't really a particular reason. It was an opportunity, came along, and I took it. I felt like it was too good an opportunity to turn down. It wasn't like I was sick of all my colleagues in the office and they were too noisy. I thought, go away, I've got to work by myself. It was just an opportunity. So what does my kind of remote team look like? Probably worth mentioning, my company is a largish company, multinational offices all over the world, but my particular team is based in the UK and US. So there's a guy in Leeds, a few people in London, 2 people in New York, a couple of people in Indianapolis, and 1 guy near Austin. That's 3 time zones. And this is my family. I only mention this because I've got to mention a disclaimer that when you've got kids, working from home, I think is quite different to when you haven't got kids. So just bear that in mind with everything I say. I can only give you the experience of working from home with kids. And so they're 5, 3, and 3. Just for anyone with kids, just to...
Is that social work in the background?
Maybe. I didn't ask. Okay, so that covers a bit of context, my remote working situation. So why would you want to work remotely? When I speak to people and say I work from home, people say, they come up with a lot of negatives straight away. I'll be distracted by the cat, YouTube, Facebook, kids, telly, whatever. But there are some huge benefits to working remotely. So the first one is flexibility. Now, you're not guaranteed flexible working when you work remotely, but I think typically flexible remote working jobs tend to be more flexible, and mine certainly is. And what I love about the flexibility is the ability to kind of fit my job around my life a bit more. So if I want to go for a walk in the morning, I can, because I just need to chill out. My brain's too full, I can do that. If I've got a doctor's appointment at 2 o'clock, I can do that. That's absolutely no problem. If I want to do anything like that, it's not a problem. Just let my team know. And it's difficult to go back to the kind of rigid schedule, I think, once you have this kind of thing. It's really good. Flexibility is tied very closely to family. So I mentioned I've got kids. Flexibility and family really go hand in hand. It's unbelievably useful to be able to just take like half an hour out of my work day to say look after the kids if my wife needs to go and do something, or pick the kids up from school, drop them off, or if my wife just needs a bit of help because the kids have all gone mental. It's anything like that. It's so unbelievably useful. Obviously, it has its downsides as well. No commute. Who loves commuting? Nobody. Absolutely nobody. My last job, I'd say I commuted for about 30 minutes each way, which that's not a very long commute, but that's an hour a day, 5 hours a week. It's roughly like 10 days a year, just sat in my car, traveling to and from work. And then there's a cost. So I bought a car to get to work, and then I had to tax it, MOT, insurance, It cost me several thousand, and I've got to spend time doing all of this stuff, which I didn't like at all. So now I leave for work at about 9:30. I get to work at 9:30. I start work at 9:30. Happy days. Happy days. You can live anywhere if you work remotely, in theory. You could move to another city. You could move to another country. Yeah?
Did you work in Edinburgh before you started working remotely for the same company?
No. No. I used to live in England, and because I work remotely, enabled us to move to Scotland without having to move jobs. So, yeah, I have actually moved countries, but you could move further afield. I mean, I suppose you're only really limited by time zone. So you could move somewhere, in Europe, possibly even like East Coast America if you wanted to. I've not gone that far, but, you could do it. You get the point. If you've got flexibility and you've got internet, you can live in a different place. More job opportunities. When you commute to work, you're kind of restricted by, the distance you're willing to travel. Is it like half an hour? Is it an hour and a half? I once knew a contractor who traveled 2 hours each way. He was crazy. With remote working, you're just restricted really by time zone. So that is that's a much bigger radius. You could get jobs for working for probably anyone in Europe. Arguably, this is balanced against possibly less remote working jobs. So this is a controversial one. Increased productivity. I believe you can be more productive when working from home, mostly because of distractions. I think you have more control over your distractions when you work from home. I'm sure everyone's been in the situation in the office where there's someone tapping on my shoulder every 5 minutes. You've got phones going off. You've got noisy conversations. You've got cleaners, all of that kind of stuff. You don't have that when you work from home. You can just put your earphones in and just concentrate for a couple of hours. You can kind of ignore Slack. And because a lot of the communication is done via email, via Slack, there's no expectation that you're going to reply straight away. People understand that if you're not replying, it's because you're busy. It's not because you're just ignoring them. So you can be really, really productive with a few provisos, which I'll get to. Freedom to choose your environment is great. Has anyone ever worked in an office where they couldn't adjust the desk, couldn't adjust the monitor, couldn't adjust the chair, or perhaps, sorry?
The temperature.
Or the temperature, that's it. Or perhaps, like a situation I had was you could adjust the desk in pairs, but the guy you're paired with is 6'9". It's not gonna work, is it? So freedom to choose environment is great. You can work in your kitchen, in your bedroom. You can buy the desk you want, the chair you want. That's fantastic. of course, you have to pay for that stuff, but nothing's perfect. So that briefly covers some of the pros of working from home, which really helped me a lot. But I'm sure a lot of you are thinking, yeah, some of this stuff is really going to suck, and it does. Yeah, terrible title for a slide. But the social stuff I find by far the most difficult thing about remote working. It's just the kind of talking to people, it's the relationships. You miss the kind of just the chit chat and banter from the office. And when I worked in an office, I took my working relationships for granted quite a lot. But not so much now, because I found after like a week of remote working, I just spent all my week talking about work. Just work all the time. I'd get to the end of the week and I'd be a bit down, and I just didn't know why. And then I'd get out of the house and I'd speak to people and I'd be buzzing. And I was like, what's going on? And I realized it's because I was missing out on the social interaction. When you're in an office, you come in and you speak to people, and you make a cup of tea and you speak to people, you go to lunch and you speak to people. None of that stuff happens when you remote unless you make it happen. So you can really miss out on a lot. And I think it's when you lack that social connection with people, it makes it more difficult. It makes it more difficult to do your job. This happens a lot, feeling left out. Particularly if you're in an entirely remote team, probably not so much. But if you're like me and you're working with a bunch of people in an office, they'll get a whole bunch of perks which you won't get. My team are going karting next month. Not me, sad face. They'll have, like, I think my company celebrated its 19th birthday, cupcakes in the office. Yeah, none for me. You get the idea. This stuff kind of happens a lot. Even the odd meeting where nobody set up a camera. I didn't want to view it anyway. It's fine. You do need discipline when working from home. This is quite a big con. You can't be distracted by TV, Facebook, YouTube, all that kind of stuff. You do need to be focused. So without discipline, you're not really going to get very far. Visibility is a tricky one. I've heard people say that when you work remotely, because you're kind of not seen, you're not in the office, the bosses aren't aware of you, you're kind of less likely to get promoted. I'm not sure if there's any proof of that. For me, I find it difficult because there's people who would be 5 meters away from me if I was in the office, who I've never even spoken to because I work remotely. And I have no relationship with, which it's just not very nice. And this is probably one of the biggest cons of remote working, which depends on your company and your job, but time zones can be a big problem. So I work with people in Indianapolis, which is Eastern time, which is 5 hours different, and a guy in Austin, which is Central time, which is 6 hours different. Fortunately, the guy in Austin gets up really early, so it doesn't make a difference. But it means people are coming online like between like 2 and 3, and that's workable. Kind of 3-4 hours crossover time is fine. Anything more than that would be really difficult. I used to work with someone in San Francisco, which is 8 hours different. So there was maybe an hour and a half of crossover time, which was always packed with meetings, and it was just really, really difficult to collaborate. I would not recommend taking a job with a time zone of like more than about 5 hours. Okay, so that briefly covers some of the cons of remote working. There's a few situations I want to mention where I would advise that you probably shouldn't take a remote job. You should just ignore the pros and cons and just leave it. I think some of them are quite obvious. If you haven't got a lot of experience, perhaps you're a grad, it's your first job. I think in this situation you benefit from a lot of face time. There's just no two ways for it. It's going to be a real struggle to work remotely. Being the only remote worker on the team, again, that's going to be very difficult because you're going to have to constantly remind your team, include me in meetings, include me in chats, make sure you set up video equipment in meeting rooms, that kind of thing. It's not going to come naturally, which is very similar to the third point. joining a company as the first remote employee, this would set off alarm bells in my head, because allowing for remote workers, it shouldn't be an afterthought. Everything should be, if you've got a lot of remote workers, or even one, you should always basically think about their needs. Is there someone, for example, in a meeting, is there someone relaying the questions from remote workers to the rest of the room? Is there someone repeating the questions into the mic so everyone can hear it? Are there cameras set up in all the meeting rooms? That kind of thing. If you're the first remote employee, chances are they probably don't have all that stuff. And the last scenario where I'd advise avoiding taking a remote working job is a time zone difference of more than 5 hours. As I mentioned previously, it's just very difficult to collaborate when you've got like an hour crossover time. And if it was like Australian, what is it, like 10, 11 hours? Just no. Just no. So, how do I make it work? So now I'm going to cover a bunch of tips which I found from reading blogs and books, and just a few personal experiences really of how to try and make remote working work. This is a really straightforward one. Get a good microphone. It's so annoying if someone sounds like they've got a waterfall in the background and you can't hear them. It doesn't have to be an expensive microphone, just like a headset or something. This is incredibly important. Meeting up with colleagues, because you don't get that social time to kind of naturally, it's really important to meet up with them when you can, particularly when you start a job. I think it's much easier to build a relationship with someone if you've met them, build a relationship remotely when you've met them. So it's worth meeting people face to face for a few days, and then just do it when you can. I mean, these things are constrained by budget and time, but just do it when you can. This is really difficult. I've really struggled with this, and I've mentioned this already. Talking about work all the time is kind of a natural thing to do. You jump into a meeting, you talk about work, you're talking about work on Slack, you're sending emails about work, but it's incredibly difficult to build a relationship with someone if you're just talking about work. So you've got to make time to not talk about work. And some of the ways we do this is we do we call it a virtual happy hour. So it's just a meeting in the diary. Everyone turns up, and the only rule is that you don't talk about work. That's it. Other tips I found work are just try not to launch straight into work. At any time you speak to anyone, like on a video call, just don't launch straight into work. Just have a bit of chat. It's also quite nice to schedule some time to play some daft games. If you can find like a free online game that anyone can play, that's quite fun. And something I've read about but haven't tried is a team integrated kind of time to chat. They called it culture time into one of their stand-ups. So one of the stand-ups was like half an hour, I think on a Friday or a Monday, and 25 minutes of that was just time to chat. I really like that idea, but I haven't tried it yet. Another simple one. When you work from home in the same room, so my desk is in my bedroom because that's the only space for it. So I sleep in that room, I work in that room. You get cabin fever, so you need to get out of the house, like walk the dog, go for a walk, pick up your kids, something. Otherwise, it just drives you a little bit insane. Regular one-to-ones. I think this is important in an office situation, but arguably more so when you're remote, simply because issues snowball a lot quicker when you're remote. You kind of build them up in your head when you're not speaking to people face to face. So kind of digging into them with your manager on a regular cadence, I think is really helpful. It also gives you time to get to know your manager because you don't have that time to chat with them, while at lunch or while having a coffee. This one's super important. You can't speak to people face to face, so video chat's the next best thing. Whenever you go into any meeting, I would always advise turn on your video. Just it's just so much more friendly. You're not speaking to this kind of invisible person. And also, I would advise, this is only something I picked up fairly recently, that if you have a meeting and one person's using video chat, just put everyone on video chat, because the number of times I've been in a meeting where There's like 3 people on video chat, there's 5 people in a room, and the people in the room, you can only hear 2 of them, 3 of them you can't hear, and then it breaks down as they start chatting and you can't hear any of that. It's just terrible. You're not on like an even playing field. Just get everyone on a video call, and then kind of you can communicate on kind of level ground. Yeah, use the great tools available. Slack or HipChat for chat. I mean, Slack's recently, in the past couple of months, it's launched a screen sharing tool, which is really, really good for pair programming. We use Google, Google Docs, Google Sheets, Hangouts, that kind of thing. Quip is great. GoToMeeting is really good if you want a meeting with a large number of people. Minimize distraction. This is really, really important. You could probably have a separate talk on minimizing distractions, but these are some of the things I do. Fairly obvious one, don't check email all the time. You can spend your entire life answering email, so just like pick maybe like midday or 3 o'clock or something and just check them twice a day or once a day or something. Social media is a really big one, particularly like personal social media. I'm quite big on this. I don't have Facebook installed on my phone. I don't have Twitter. I basically turn off all my push notifications to try and minimize distractions. I just have the essential stuff on. Also, one of the biggest sources of distraction for me is Slack at work. I think I'm in 2, what do they call them, workspaces, and within that I must be in about 30 channels. It's just ridiculous. I'm being pinged all the time. So to minimize that, I don't keep it open on my second monitor, because if you see a message and someone mentions you, you kind of want to reply straight away, so just don't look at it. If you want distraction-free time, like snooze it for an hour. Particularly snooze it during meetings, because one of my worst habits is trying to listen to someone who's speaking to me and trying to type out a message on the other screen. It's a really, really bad habit. So I avoid doing that. I think having a routine is very important. I find it easy because my routine's around my kids, but I hear that people without kids, they struggle to kind of separate their work and their home life. So typically, people can do a lot more hours, and that can lead to burnout. So best avoided by having a routine. Say, like, I'm going to start 9:30, 10, and then log off at 5:36, something like that. Visibility. So I mentioned this as a con. So what do you do about this? So I see this in kind of 2 ways. One's visibility outside the team, and visibility inside the team. So visibility outside the team, I find this quite difficult, and all I can recommend is just to try and run technical talks, kind of attend ones that are on, ask questions, try and reach out to people, perhaps to learn from them, that kind of thing. Visibility inside the team is, I find a lot easier. It's basically just a case of letting people know where you are and what you're working on. When you come in the morning, you log on, you say morning, and people know you're at your keyboard. When you leave, you say, I'm off, bye, little wave emoji. People know you left. If you're popping out for 30 minutes, you tell them. We call it a status channel, so it's just, there's no chat in there. We just put what we're working on when we're working on it. Obviously, a lot of people use stand-ups. We only have a stand-up and be twice a week, because we found it wasn't really working that well. This is not a great slide title either. And this applies to the office as well, but I think it applies more to remote working, because so much of your communication is it's via Slack and email. So some of the things I found useful here are just making sure you're using the right medium. Do you really need to dig into something? Use video. Do you want to have like a kind of casual chat about something and it's not super important whether you get an answer right away? Slack's great. Do you want everyone to read it but they don't need to reply? You don't need to reply today. Use email. And also, if you're emailing people in a different time zone, it requires a little bit of extra effort to avoid email tennis that lasts like a couple of weeks. Just put some thought into what do they know, what do they not know, have I included all the information they need, that kind of thing. And another quite important tip is when you're communicating with people via Slack or email and you don't know them very well, you haven't got a very good relationship with them, you don't know kind of how they speak and how they write, it can be very easy to take things very negatively. So if possible, always assume that somebody's coming from a positive place. They're not having a dig, they're not having a go. If you don't do this, it can get quite bad quite quickly because you're not resolving these problems when you meet them face to face because you don't do it very often. And my last tip was just always continue to learn about this stuff. These are some of my favorite resources. Motive.io posts a bunch of blogs every week or so. The Ultimate Guide to Remote Working is free and written by Zapier, which is full of great tips. Remote is probably the most widely known remote working book, but probably not my favorite. How to Embrace Remote Work is very good. That's another free one by Trello. And a recent survey is The State of Remote Work, which is by Buffer, which contains some really interesting statistics. Like apparently 90% of the people in this survey want to continue to work remotely for the rest of their career, which I found interesting. I don't think I'm not in that 90%. I'm not very sure. So that's it. I've covered some pros, cons, when not to work remotely, how to make it work, and that's it.
Thank you. I got a little wow. Got a little bit of a question. So I'm gonna start working remotely as the first person in my company in about a month and a half, sorta. So you said I shouldn't do it. So, but I'm gonna do it despite what you're saying. So any advice you can give me?
Yeah. I have a friend, an ex-colleague, who did this, and it worked for him. But just if you feel any pain, like feeling left out or if things aren't set up, just tell them straight away. Can we get a camera in this room? Can we, particularly the one about the if one person's on a video call, make sure everyone is. Now that's going to be really weird, I think, for people in the office, but I find that works really well. So just feedback your pain points as soon as you spot them, I would say, to your manager. That would be my advice.
Thank you.
Is the salary of comparable employees dependent on where they're remote working from?
I have no idea.
What about in your case? Is it, like UK employees are getting the same regardless of in the UK where they are? What about the Americans? Or
I have no idea, I'm afraid. Yeah, nobody tells me their salaries.
Well, corollary to that, do you feel you're getting paid the going rate for living here?
I don't know, because I've spent 10 years working in the northeast of England, and I've only spent a year working in Scotland, and I've not been looking for jobs, so I don't really know what the salaries are like here.
Are you paid the same as you were when you lived in northeast of England?
No, but that's not really relevant. So so I suppose compared with the northeast of England, I'd say the salary was absolutely fine. Yeah.
Sorry. Give a bit of input to that, because I was in a situation where I was working for a company based in Germany, and I just kind of said the salary that I would have expected to be paid here, and they were happy with that. But maybe from Germany, it's a bit beneficial for them, perhaps the exchange rate. But I guess you would just start with, for me, I would just start with what you want, and then go from there. If they push back, you can always go down, possibly.
I can also try to answer that question, which kind of feeds in with what I was going to say. I work in the financial services, and with banks, they're very much paid the local rate. So we work with a lot of Indian teams. They earn peanuts, and they work way more than we do. Sometimes UK hours, which is insane. So I think it really depends on the industry, which kind of feeds into not a question, more sort of an observation. I kind of feel that everything that you just said should sort of come with a caveat of two things. One, what you were talking about, I think, is very sort of job dependent. Like for a coding job, working remotely is very different than the sort of job that I do remotely sometimes, which kind of ties in with the next point, which is it also depends on the size of the company. So once again, in the financial services, all the big banks are now doing this. It's compulsory to work from home 1 day a week. So RBS, HSBC, I could go on, they all do this. And working from home 1 day a week is drastically different from what you just described. And for example, we all use Skype Messenger or whatever, which obviously the bank installs on our machines, and you have to respond to that. So it's not like you can switch off Slack. You have to respond to it because otherwise it's like, well, you're not working.
Right.
So just sort of some kind of caveats in terms of the industry.
Some excellent points, which if I ever do this talk again, I will mention. Yeah, so I am a software engineer and I'm working from home 100% of the time, which, as you say, is totally different from the occasional working from home. Yeah, for sure.
One last question. No. Right. Thank you very much, Phil. Right. So we're gonna take a quick break while we set up for the second talk. So yeah, we'll start in about 5 minutes or so. Feel free to grab a drink or any pizza if there's any left. We're gonna start the second talk of the evening. Right. I guess while some people are still away, I'll just say. Yeah, so TechMeetUp is a volunteer-run kind of event, and it kind of I guess it needs people to run, and we're always looking for speakers to come and give talks at TechMeetUp. So if you enjoy it tonight, and if you feel like there's something you'd want to talk about, just come and talk to me, and we'll put you on a list and get you to give a talk at TechMeetUp. Right. Shall we wait a minute to what?
They need to wheeze their way in.
Right, 2 minutes. I'll give them 2 minutes. So out of curiosity, like the people who came here for the first time, how did you find out about it?
You told me.
Yeah. Okay, apart from you. Anyone know?
Like Twitter and Chris told him.
All right. I guess we're, yeah.
You're listed in weekly events.
All right. Okay, that's good to know. I didn't know that. So even though we're kind of feeling in marketing, like people are doing that for us.
No, it's been ages since I've been here for the first time, but I remember when I first moved into Edinburgh, like a year and a half ago, more or less. I was like, well, I need to find a job and I need to meet people because it's getting boring playing in Blue at home. So then I was like, okay, well, what's the soonest thing happening? So then I went to Hack Lab. There was this guy there. So then we were talking. It was funny because he moved to Finland and I just came from Finland here. And so we kind of exchanged places, and then he's like, hey, there's this meetup, also free beer and pizza. so why don't you come there in a week? I'm like, yeah, perfect. Then I came here, yeah. But I also wanted to mention that you forgot to ask the people who won't come here second time to actually tell us why they won't come here second time.
That was Douglas who was asking.
They never tell us.
Plus, they may have already left.
Right. Well, I think we're going to start. Yeah, so for the second talk of the evening, and after this we're going to the pub at Doctors, just putting it out there so you know what the plan is. So we've got Stephen talking about GIS, right?
Yes, that's right.
Take it away.
Cool. Good evening, everybody. Up until about 8:30 this morning, my talk was titled GIS for School Children and Software Engineers. And then I woke up this morning and discovered that Professor Hawking is no longer with us, so I decided to do a quick rename of my talk. Yeah, I'll give you a few minutes just to wipe the tears from your eyes. No? Okay. Yeah, he was one of us, and he's gone on ahead, no longer with us. So he's definitely one of those people who history will judge very kindly, I think. So a brief history of GIS. What am I going to talk about? Well, first of all, I'm going to talk about me. So I'm Stephen Meyer. I did computer science in New Zealand. Got kicked out of New Zealand kind of 2000, got told to go see the world. So I did that. First of all, I was in New York. Worked in New York for about 5 years. And then decided now for something completely different and came to Edinburgh. So that was in 2005. At that point, there was a young woman who said she was coming too. So I said, fine, that sounds good. And then, yeah, we kind of just forgot to leave. And I guess we could say we really like Edinburgh, so that's why we've stayed. So that was, yeah, a few years ago now. So still here though, absolutely, this is home now. Very happy to be here. Currently working for a company called Sigma 7. We do GIS systems for utilities companies. So think power, think water, gas, some other ones you might not sort of know about. Railways, you know, they have a lot of infrastructure, need maps, things like that. Environmental agencies that are dealing with spills and monitoring and all that sort of stuff. So there's some other people we deal with sort of on the periphery, but primarily target utilities. And we do a cross-platform solution these days, so it runs natively on Windows, Android, iOS, whatever the client comes to us. You know, they say this is our platform, and we say, sure, that's fine. That's an email address if anyone wants to get in contact with me. And then I was trying to think of a grandiose title, and Stephen's theory of life was kind of about as good as I could come up with. So my theory of life is this. If you think about people who you know, you think about to when you went to high school, think about university, and then think about those people you knew then, where they are now in life, and like how many people really had like a plan that they've executed, you know, and how many people had a goal in life that they've got to, versus how many people kind of just fell into something. You know, they met someone and someone said something and they went there, and you know, a lot of people I know, and definitely absolutely me, just fall into things. And I fell into GIS, and that was a few years back now, but you know, sort of a happy coincidence to some extent. I got a job that I liked the sound of, and it went from there. So the trick is to surround yourself with the sort of things that whichever way you happen to fall, you're going to end up somewhere interesting. So there, that's my life lesson over. Back to GIS. So the first question, of course, is what is GIS? What the hell does it stand for? So Geographic Information Systems. If you've got information that's in any way related to a location, and you want to gather that together and you want to look at it and analyze it and play with it and make decisions based on it, that's a GIS type solution. And what it will do for you though is it gives you deeper insight. It gives you the ability to spot things that you might not have otherwise seen, or to see things a lot quicker. So as I've said here, relationships, patterns, different situations. And you can think of it as the difference between a spreadsheet and a map. So if you have a spreadsheet of information and you're looking at that and you're thinking, what is that showing me? What's the big picture here? What am I trying to understand? And then someone shows you that, and you say, oh, right, yes, okay, that makes sense. It's population centres in the UK. You know, so there's things that will jump out at you instantly when you look at them on a map, or when you're doing kind of a GIS type analysis, versus days and days and days of fiddling around with database queries and spreadsheets and really getting nowhere. So that's what GIS is. We're now going to do a little aside here and go to my quick discussion about mapping in the UK. This is why it's GIS for school children, because we have here a handy using the national grid. So this is something that I give out to new software engineers who join our team. Very briefly, we are here. The UK is divided up into grids. 00 is southwest corner. How do you say it's pronounced, Douglas? Not Isle of Scilly? Scillies. Isle of Scillies, yes. So they're floating off there somewhere in the sea, and everything counts up from there. The National Grid happily have nice two-letter prefixes to describe various regions. I used to think that N was north and S was south, but then I discovered there was H's and there was T's and an O, and my analysis kind of fell down at that point, so I don't know. We have a hand up.
So is this an industry standard naming convention, or is it something you guys came up with?
No, this is government, basically, yeah. So there's an organisation in the UK called Ordnance Survey that is sort of the UK's mapping organisation, and that's what they've produced. So absolutely standard, any mapping solution in the UK will absolutely use this system, will be capable of it, yeah.
Is Northern Ireland not in the national grid?
Yes.
I don't know the answer to that.
This thing.
Yeah. If I was to scroll that way, is there like other ends?
It's south of that,
Yeah. I don't think so. I think it's just for
Great Britain.
yes.
But not
Yes. No. Well, no, wait. See, look, I can go up this way.
Okay.
See? We do go north, we just don't go west. Yeah. So anyway, we've got 100 by 100 grid squares. If you know the two-letter prefix, you can get down to 100 by 100K. Of course, that's kind of useless if you're trying to find the local pub, so you need to go a bit more detailed than that. So now say we're in TL, so we've got TL, happens to be London, how convenient. So now we need to say, all right, within this, I'm now going to start again 0, 0. So now I'm 0, 0, but happen to be offset to this location. So I'm now going to say, I want this square here, so I now need to go my eastings first, and I'm going to go along to 6, and then I'm going to go up into the 3. So I'm now TL63. So that's then taken me down by a factor of 10. So I'm no longer 100 by 100, I'm now down to a 10K by 10K square. And of course you might want to go even further than that. And so you've now got TL63, and you can then, of course, divide that up into 10 and find your location in one of these squares. And now you've gone from 100Ks down to 10Ks down to 1K square, and so forth. And each time you do a step in, you add another number, you get another sort of factor of precision. So yada, yada, yada. Let's find some places here. So we have to find the church at TL 683365. We happen to be on the TL square here. We're going to go to 683, so that's going to be 68. There we are. That's that line there. We now need to go to about a third of the way in there. We're then going to go up to 365. There's 36. We need to go about halfway up. So we're there, 365. And there's a little church symbol there. Honest. I'd zoom in, but it's really there. So that's how National Grid works. All right, everyone got it? You're all experts. Right, move along. Okay, back to this. Ching. So, now, this is important. This is the first rule of mapping. There is something wrong with this map. Who would do such a thing? Who would make a map like it? Who would go to such detail to make a map without New Zealand? Happily, if you want to know more, there is a whole website devoted to this.
No Alaska.
Right, moving on again. History of GIS. So this is the brief history of GIS bit that the title alludes to. Term came up 1968 was the first scientific paper with it in. Kind of mid-70s, there was some academic interest. People were starting to develop systems. And the first kind of computer system came out mid-70s. There's a few claims to fame, but certainly one that a Harvard computer lab came out with is one I'm aware of. The first GIS meeting in the UK was apparently mid-70s. I don't know where it was. I don't know how many people attended. I don't know if it was just a meeting at a pub or whether there was sort of anything more formal than that, but that's what I read. Moving on, it's kind of still quite academic focused, military and kind of industrial stuff. 82, there was a mini computer system launched by a company that is now known as ESRI or ESRI. Forget what that stands for, but the kind of big player in the industry. So they're very well known, and a lot of people use their systems. So that was 82. 86, there was the first desktop version came out for desktop computers running on DOS. So that's gone kind of from 1970 through to mid to late 80s. The next kind of phase, I think, is the internet arrives. I remember seeing my first web browser in probably 93. I remember seeing Mosaic running on a Sun workstation. I didn't know the name of any website, the URL to go and find one, so I can remember not really being able to do much of anything on it, but that's kind of, early 90s. And then MapQuest was one of the first I know of that was sort of an online mapping solution, GIS solution that started to be available. By what we've got available today, it was very primitive. But that was, mid-90s was kind of the launch of internet maps. About 10 years after that, actually, Google Maps launched. 2005 was when Google Maps launched. Google acquired some companies, as is their want. I think it was a Scandinavian company, but I'm not sure. I'm trying to remember now. Anyway, so Google Maps got launched 2005. The next important thing is that November 2006, I came on the scene, got my first GIS job. So I got a job working for a company that did seismic surveys, so oil and gas industry looking for what's under the ground. And they would set off an explosion with dynamite, or a big truck would set off a signal, goes down to the ground, bounces back up, some sensors would pick it up, and then if you crunch all the numbers and everything, you could do a map of what was under the ground. So that's where I kind of got my taster for GIS. Google kept innovating, and between 2007 when they launched Street View, then went on to do smartphone version until I saw statistics that for August 2013, Google Maps was the most popular app in the world. So we've gone from kind of nothing in 1970 to absolutely ubiquitous and the most popular smartphone app on the planet by mid sort of 2010, 2015 era. So that's kind of the history of GIS. There's a nice quote by Douglas Adams. He's got some rules that kind of explain new technologies. And if something exists when you're born, then that's basically just the natural way of things, and it's completely normal, and it's like breathing air and drinking water. You can't imagine a way or a time where that didn't exist. If something is invented and sort of comes on the scene between maybe when you're kind of in your teens and maybe early to mid 30s, then it's the coolest shit you've ever seen, and you can probably get a good job out of it. And it's just the latest, greatest thing, and everyone's talking about it. And then if anything kind of new comes on the scene after like mid 30s, then it's some newfangled invention, and you probably don't want anything to do with it. So, so that's kind of, I think, where GIS has got to now, in that there's a bunch of older people who will still use paper maps because that's what they do, that's what they know. And then there's little kids today who have never known a time without the entire world's maps, satellite photos, everything in the palm of their hand. So an interesting little journey. What happens next? I don't know, but it's going to be a wild ride, and I look forward to it. So there we go. On to a little bit about how digital maps work now. So first thing to be aware of is you have layers, you have map layers. Typically, if you're looking at a two-dimensional map and not a three-dimensional map, you obviously have, as I just showed you in the wee demo before, you've got an easting and a northing, an X and a Y, you've got coordinates to locate something on a map. But typically with GIS systems, you also have a Z order or a vertical order. How that tends to work is that you can layer things so that the full view that you see is composed of a bunch of different things, maybe different data sources, and when you put it all together, you see the big picture. Now you can also play with it, and you can highlight things, you can hide things, you can put transparency on, so you can sort of see faint shadows of things underneath. You know, there's all sorts of stuff you can do. Typically, if you are at the top level, you want to have text. So any text you want to read, you want that to be clearly visible. You put that on top. The next layer down, you tend to put points. So if you've got a symbol, you want to drop that on the map next. The next layer down, as you go down the stack, you would do lines. So anything that's a line, if you're drawing a road on a map, the outline of a building would go below those. And then finally at the bottom, you want to put polygons and satellite images, or tiles that are an area that would obscure things. So they sit on the bottom. So you build yourself up a stack, and then what the user sees is that one at the bottom with everything looking lovey-dovey. So that's one thing, map layers. Now, what are those map layers made of? It says data layers, but where does that come from? Okay, we've got a data source over there. Right, what does that look like? So, two types, vector and raster. Very briefly, one is using coordinates and one is using images, basically. So those are the two types. So raster data is, the classic example these days is satellite images. If you've got satellite images that you want to put underneath your maps, there's all sorts of other things. You might have scanned historical maps that you want to put under modern data. You might have elevation models that you want to put underneath, all sorts of things. Typically you'll have a rectangular tile. It might be 1,000 pixels by 1,000 pixels. Each of those pixels has its own particular value and will be rendered accordingly. Now, there's some issues with that though. So we're going to do a quick demo here. We have some raster tiles to look at. One of those. So there's some raster tiles. Each of these you can see is a 2-letter prefix. So that comes from the Ordnance Survey National Grid that we just talked about. If you have a look at these, that one over there looks interesting. Let's see what that is. And lo and behold, there is Edinburgh. Now, the downside of rasters, so this looks great at this level. Or actually it doesn't, because you can't read any of that, but on my screen it's perfect. Okay, we can't read it. So let's say we want to zoom in. So we're zooming in. Okay, that's starting to get a bit more legible. Let's zoom in a bit more. Okay, that's starting to look a bit more readable. Okay, that's cool. Zoom in a bit more. Oh, that's not looking so good anymore. So because it's pixels, when you zoom in, there's a limit, and beyond that, it just looks rubbish. So the way to work around that is, of course, you can have raster tiles that are at different resolutions or different scales, and then you can zoom in and things will change. So if I go here, we now have, this is at 1 to 1,000,000. If I was to zoom in here to 1 to 500,000, that would look a bit better, zoomed in. Okay, let's see, I think I've got some bookmarks here. Yeah, there we go. So if I zoom in a bit again, I'm going to go into 1 to 200,000. Right, so now I've changed actually to a different tile. I've got a different data set. So that looks better. Now if I zoom in on that one though, we saw that got to a point where that wasn't readable. So what happens if I zoom in again, 1 to 50,000, we change again. So that's the way around that, is that at different scales you'll have different data sets available. So that's a quick demo of rasters, how they work, and they're all tiles, as you could see here. They're made up of tiles. Each of those will be 100 k's by 100 k's square. And then when you look at it on a map, your GIS system will do it such that you can't actually tell where the tiles start and finish. But if I zoom around, you'll see it, presumably, unless it's too quick, you can see it, some of the corners drawing in new tiles as I zoom around. There we go, there's one. You can just see it drawing in there. So that's how a system will work, but you can't, by looking at it, tell where the seam is between the tiles if it's done well. Right, back to this. Ta-da. Onwards. So rasters we talked about. The alternative is vector data. So that's where you have points with coordinates, you have lines, you have vertices, paths. The simplest thing is a point that has an easting and a northing, or an x and a y. That's a single point on a map. If you take 2 points and join them up, you obviously have a line. You may have lots and lots and lots of points, play connect the dots, you've got a very, very long line. And if you were to close that line, so it's now a closed shape, that becomes a polygon. So that's pretty simply how you can talk about it. So if you're doing rasters, obviously you can just store them on a file system, you can download them out of the cloud, whatever you might want to do. What do you do with vector data? Well, you probably want to store it in a database. So luckily there's lots of solutions for that. All the big providers have a GIS or a spatial capabilities. So Oracle SQL Server do. Postgres has PostGIS, which is very popular. Work, I use SQLite because we're doing mobile devices. So we use SQLite, and there's a plugin or an add-on or extension for that called SpatialLite, which gives us all of the functionality we need. MongoDB, was a chat of that a couple of months ago. So Douglas says that's also got spatial information in it. So that's obviously not a relational database, it's quite different, but still can store information in there that has coordinates and stuff. So SQLite is the one that I'm very familiar with. You want to store this information now. Well, the problem is that you don't really know how big it's going to be. If you've got a point, that's easy. That's 1x and 1y. If you've got a line, how long is a line? Well, you don't know. It might go on forever. It might be very big. Particularly if you've got curves. How do you draw a curve? Well, you chop it up into lots and lots and lots of tiny little lines. So you can end up with lots and lots of points, which of course needs then a certain amount of storage space. How do you deal with it? You put it in a blob. So the bulk of the implementations for spatial data types store information in blobs. That's lovely because now the database can handle that. But what about the developer writing the code? What about the user who wants to look into the database and check stuff out? Well, we need some way to be able to get it as a human readable form. So there's of course industry standards for that. There's one called well-known text and well-known binary, and there's ways you can transfer data around between systems that may have different implementations of their blob data type. You want to be able to run queries on it. And then if you want to run queries on a large data set, you're going to, of course, need indexes. And so there's spatial indexes in those database systems as well. So you can have decent performance when you're looking for, all the objects that are within a certain area or something. So spatial queries, spatial indexes, very important, very useful. The well-known text that I mentioned, there's a quick look at it here. So you can see there's some examples. There's a point, you need an x and a y. Here's a line, this one has 3 points joined up, 1, 2, 3 points. If you have a polygon, now we've got 4 points that are closed, 1, 2, 3, 4, 5, because we have to close and get back to where we started from. And then there's some other silly one at the bottom, don't worry about that. Right, demo time again. So we'll pop out of this. We'll bring up SpatialLite GUI. No, that's not readable. Right, how are we going to... we should be able to go like that. Yeah. Okay. Is that readable now? A bit more? I can go one more in if that helps. That's all right? One more? All right. Better? Okay. Now, of course, I have to make this smaller. Yeah, and then we'll put that over there, and then we can go like that. Okay, that'll work. Good. Okay, so I've got a database here. It happens to be something called Master Map, which is information from Ordnance Survey, who I mentioned earlier. So we're going to do some querying in that. So, of course, I've got to go all the way over here to, right, that's not going to work. Okay, let's see. That can go to there. No, that can go to there. Oh. This is not going to prove to be easy, is it? All right, that'll work. So run my query. All right, so here's the geometries. That's it in a blob form. That's fantastic. That tells me precisely nothing. So there is spatial queries I can run to take a look at that. Let's see what sort of information's in there. Ah, great, those are all points. So I know this table now contains point data. That's useful, a little bit. I want to know where those points are. So how do I tell where those points actually are as opposed to just that they are points? So now I can convert those into the well-known text format that I talked about. That's much nicer. So now I can go and look at one of those. I should be able to go and find that manually on a map. I've got, ooh, don't do that. I've now got an X and a Y, an easting and northing. I can go and find those on the map. I might want to transfer this information from one system to another. So that well-known text might be quite useful if I'm trying to pass that from one application to another. Maybe I want to convert it into hex, and then I can just stream it somewhere. So there's options that you can use in these spatial queries to get the information out of that binary object and take a look at it. Likewise, if I want to insert information into my database, I want to create geometries, I can specify a point, a line, a polygon, whatever my shape might be, and then it'll happily convert it into the geometry for me. So that's how I can get information into the system. So that's useful. Right, so we can get stuff out, we can put stuff into the system. I can also do queries for regions. There's a whole lot of abilities to do queries within where stuff contains, where it intersects, where, there's all sorts of kind of spatial operators you can use. So as a very brief example though, I might want to just say, look, I want to do everything where the X value is less than there. And so if I were to execute that, it's going to now scroll across, find everything where the X value, the easting, is less than 222,000. So lots of spatial queries you can run. Polygons behave very similarly. So there's now a table with polygons in. So you can see that polygons are now made up of a bunch of points. And I can then trim out and extract all the points out of those polygons. So if the polygon was composed of 10 points, I can then talk about the first or the last point, or I can step through each of those points and then manipulate objects accordingly. So that's kind of a brief introduction of how you can get through stuff in your database. There's a lot of other spatial operators and queries you can run. So I might want to find out the area of things. That's great. I don't need to write any special code that does that. The database engine will handle that for me. I might want to know the center point of my polygons. That's fine. It'll find the centroid for me. That's interesting. It's happily converted that into a blob, which is precisely not what I wanted. So we'll just add in a bit of well-known text there, and that should be now something I can go and find that center point on the map, manipulate that, do whatever I want. So spatial databases, very powerful. They range from small, lightweight things to big enterprise level things. Yes?
Can you also do any normal SQL as well as this?
Yeah, absolutely, yes, yeah. So one of the little tricks to be aware of though, so you can write a query that combines regular columns with spatial columns. The trick is to do with the indexes. So you might potentially have a table with a regular index on it. You know, you've got a column that's an integer, and you've got a column that's geometries, and you've got a spatial index on that. In my experience, almost invariably, you're better off using the spatial index. So if you're looking for all the letterboxes, all the mailboxes within a certain area, rather than saying, of all the million points I've got, find me all the mailboxes, and then find all the mailboxes within this area, you're far better off going the other way around, saying, find me everything in this little area, and then go and filter it for all the mailboxes. Depends on the implementation, yeah. So you can, I mean, the way we have our databases set up, it absolutely will go for the spatial index first. You know, how database engines come up with query plans is sometimes a bit of a iffy kind of, you know, subject. So absolutely, you can tell it, you can give it hints, and you can set up your databases and your index such that it will do it that way. But yeah, running a query against an integer column and a geometry column is fine. You can do that fine, yeah. So that is databases. So now if we were to kill my thing and go back to here, had a few more little resources to pass on. Anyone interested in getting into GIS stuff? OpenStreetMap is an interesting organization. They are basically a free wiki-style map. Anyone can edit it. There's meetups, started in the UK, and there's certainly an Edinburgh meetup group, and lots of ongoing development work there. The Ordnance Survey I talked about earlier, they've got a lot of data sets. Some of it's proprietary and licensed, but some of it's freely available. So if you're looking for information, they're a good place to go. And then QGIS is a good open source application that's very powerful, cross-platform, open source, and a great place to get started. So that, I think, is all the stuff I had prepared. Any questions from people?
How do you decide how to index on geospatial columns?
So just like you'd add a column into a normal database and you say, this is a column I'm going to expect to do queries on, I'm going to add an index to it. So you can say, I'm adding a geometry column, I'm going to store geometries here, I'm going to want an index on that. So you just tell when you create the table, you just say put an index on that column.
I guess, what is it? I'm struggling to picture how an index works in a geospatial column. Because you've got this blob of data.
Very, very briefly, trees. So, yeah, there's ways that you can construct index trees that will enable you to do spatial indexes. Yeah, there's a lot more to it, and I understand a portion of that lot more, but that's probably over a beer at the pub type discussion. Yeah. Yes.
If you're building something like a web app and you're using all this database specific functionality, does a typical web app programming language need anything special to use it, or is it all just kind of the database is doing all the hard work?
Really depends. So depends on what your database backend is. Certainly there is APIs available for Oracle and SQL Server and those big players. You can, of course, just have a string which contains your query, open a database connection, fire it off, get back results. That's absolutely fine. Or there's more integrated ways, APIs that you can use to get into things. It basically just looks like a standard database query though. So if you've got the right modules or extensions, whatever it might be, any regular data access layer, you've got, data objects, whatever you might have in your system. It's just an extra little piece to add in spatial stuff and then just start playing with it. It's not really, certainly in my experience, it's not, you don't treat it particularly differently than regular, non-spatial data. Yeah. Right at the back.
Just wanted to ask if you're aware, can you come up with at least one single holy war subject for GIS developers? You can argue that you should write query this way, and everyone who writes query the other way is just a noob. And same thing about frameworks. So what's the thing about the GIS systems? Is everyone happily all coding the same thing together, or what's the common point of arguments? Pointless arguments.
Well, one sort of compatibility issue is what coordinate system you use. So you can have latitudes and longitudes, you can have eastings and northings, whether you're talking about stuff that's coming in from a GPS satellite versus stuff that's coming off a historical map. Those points refer to something on the Earth's surface. Now, the Earth is not a lovely round ball. It's a sort of a slightly squashed, pushed out thing. And there's various equations that people have come up with that describe the Earth's surface. And some of them are more or less accurate than others. And depending on where you are on the Earth's surface, they're more or less accurate as a representation of that point on the Earth. And if you have a location that has been projected differently onto one of these different coordinate systems, these different projections, the same point could actually be meters and meters apart. And knowing what form your data is in and how your system works is therefore important. And even in cases where people know what they're doing and do it professionally, you can still get incidents where, the data is wrong and screwed up. Or it'll be fine on one side of the map, on the west side, and you scroll across to the east and everything's out by, some tolerance or whatever. So not really a religious war such type issue, but certainly lots of room for incompatibilities and pain. Yeah.
Thank you.
Cool. Douglas at the front.
Sorry,
Yep. Here comes the mic.
I noticed all the examples you gave of lines and polygons, they're stored in absolute coordinates. Would
Yes.
you use relative coordinates after the first one ever?
You certainly can. So everything is relative, really. You need some point of reference. And so if you're talking about a particular area, you can quite happily define your own point of reference. Or it might be, as you said, that your first point that you place on the map becomes your point of reference, and then everything else you just know relative to that. But you've still got to know relative how. What are you talking about? If you say one's at 0, 0 and one's at 10, 20, 10 what, 20 what? Oh, well, now we need to have meters or feet, or, so, you've obviously got to define the system you're working in. But once you've done that, then really, to some extent,
You need the north orientation as well, because 0, 0, but you don't know which way.
Yeah, right. Yeah, you need to define. Yeah. Your axes. How do they work? Some systems, instead of doing an x and a y or an easting and a northing, will do. Starting from a point of origin, they'll have a direction, like a vector sort of thing would be like an angle and a length or something like that, and so you can define things that way. So there's different ways you can specify things. Yeah.
One last question. Actually, two.
Two, okay.
Thank you. Hi. Well, when people started making maps, first there was a problem because the Earth is more or less spherical, and when you translate those shapes onto a flat piece of paper, there might be some inaccuracies, like distances may not be the same depending on the latitude and longitude, or you get different types of maps depending on what features you want to be more exact, more precise. Is there such problems with the GIS?
So certainly if you're projecting a map onto a two-dimensional surface, you're projecting a sphere, a globe like the Earth, then yeah, you need to know, there needs to be some system for achieving that. And so of course, people have come up with various projections and ways of doing that, and that's fine. If you're talking about a GIS system, then typically each of your coordinates is actually a coordinate that's projected onto a curved surface. So because you've got these equations, these projections, these coordinate systems, you can say this point here and here are actually points on a curved surface, and I'm then going to flatten that and display it on a two-dimensional map on my screen. But the actual location, that's been taken into account, by these projection systems. Yeah. I mean, if you're viewing the whole Earth, you've got to make a decision about how you're going to project the entire Earth's surface, which is obviously wrapped around a three-dimensional shape, onto a flat one. If you're talking about a very small area, if you're talking about a 1 kilometre by 1 kilometre location, then it's not important particularly at all, how you do that. So certainly you have to be aware of that, particularly at higher scales and stuff, where it becomes more apparent the curvature of the Earth, Yep.
Yeah, my question can be related to that question, because we know the continents are moving. Tiny moves, but they're moving, they changing the position. How the GIS systems work with this? It's relevant or not? Because the points on the map changing in some way, tiny.
So, I mean, typically a lot of continental drift is like kind of on the millimeters per year type thing. So anything at kind of a human scale doesn't really change, but a lot of people do take that into account. If you're a seismologist, if you're someone who's studying earthquakes and you've put out a couple of very accurate GPS sensors either side of a known fault line and you want to see them, then yeah, you need to be very careful about that. GPS, as I said, just mentioned, if you've got GPS, those are coming from obviously satellites that have a fixed known position over the Earth's surface. So if the continent is moving over that point, then you can absolutely detect that. So typically the maps that I work with doesn't matter at all, but there's definitely applications where that's quite important that they take that into account. Yeah.
Can we leave it for the pub? Yeah, cool. Right, it's getting late. Thank you.
Yes.
Thank you, Stephen.
No problem.
So what we're going to do now is going to head over to Doctors for drinks. Everyone's welcome. Thank you very much for coming, and thank you to Skyscanner, Cultivate and Informatics Ventures for sponsoring, and hopefully see you all next month, the second Wednesday of the month. Thank you. Let's go to the pub.
Thank you, Marius.